Welcome students to IIT and GATE classes. We are here to discuss GATE 2020 solution for power system topic in electrical engineering paper. So without further ado, we will see the weightage. So weightage is like this. So question number 8 is from power system protection, carries 1 marks. Question number 9 was from load flow, it carried 1 marks. Question number 23 from load frequency control carried 1 marks. Question number 29 from load flow carried 2 marks. Question number 43 from performance of transmission line, it carried 2 marks. And question number 49 from symmetrical faults, it carried 2 marks. So total questions asked was for 9 marks, and therefore it gives about 9% of total syllabus coverage. So very important topic, this power system for electrical engineers as far as GATE examination is concerned. So this has been taken from GATE official source, that is gate.iit.ac.in. So without further delay, we move on to solution of these questions. So first of all, we take question number 8 for E paper. So question number 8 is a lossless transmission line with 0.2 per unit reactance per phase uniformly distributed along the length of the line. So reactance is given. So reactance is given as 0.2 per unit per phase uniformly distributed along the length of the line, connecting a generator bus to a load bus. Okay, so a generator is there. Okay, so generator is there. This is generator bus PG. A load is there. It is connected to load bus BL. Suppose this is transmission line. It is a lossless transmission line, therefore there is no resistance, only reactance is there, therefore this is JX. This is JX. So reactance of transmission line is JX. Okay, so it is said that it is protected up to 80% of line length. It is protected up to 80% of line length by a distance delay placed at a generator bus. So this is generator bus. A distance delay is placed at the generator bus. So suppose this is a distance delay given by a cross. The generator terminal voltage is 1 per unit. So generator terminal voltage at the terminal, that is at bus bar, is 1 per unit. This is generator terminal voltage VPU. VPU is 1 per unit. There is no generation at the load bus. There is no generator connected. There is no infeed at the load bus. Okay. The threshold per unit current for operation of distance delay for a solid 3-phase to ground fault on the transmission line is closest to. All these 4 options are given. You have to choose correct one. Okay. So threshold per unit current. So threshold per unit current for operation of distance delay. So threshold current means pickup current. Okay. This pickup current is nothing but current at which relay just operates. At which relay just operates. So let us suppose that current is I per unit. Okay. So as per the distance delay formula, X per unit is nothing but V per unit divided by I per unit. So from here you need to calculate I per unit, that is V per unit divided by X. Now it is given that it is protecting, this relay is protecting only 80% of its line length. Okay. Now total reactance is proportional to, that is given by reactance per unit length into length of transmission line. So reactance is proportional to length. So X per unit is equal to 0.8, since it is protecting only 80%. So 0.8x. 0.8x. So substituting the values. So 0.8 into 0.8. Okay. So this is 0.16. So what is I per unit? I per unit is 1.0, that is V per unit, divided by X per unit, that is 0.16 per unit. So I per unit is equal to 6.25 per unit. So option D is correct option, 6.25 per unit. Okay, so this is the answer for question number 8. Now we move on to question number 9. So what it says, out of following options, the most relevant information needed to specify the real power P at the PV bus in a load flow analysis is solution of economic load dispatch and rated power output of generator, rated voltage of generator, base power of a generator. So as far as PV bus is concerned, at PV bus real power and voltages are specified. Okay. So to specify real power at different branches and different buses, we need to have economical consideration. For realistic load flow results. Okay, for realistically correct load flow result or for practical load flow result. So correct option for this will be, we need to have solution of economic load dispatch. So option A is the correct option. We now move on to question number 10. Okay, sorry, question number 23. So question number 23. So we'll formulate this question. Okay, this question is for group characteristics. So we'll draw the group characteristic first. So first of all, we see a single phase 50 Hz generator. So single phase 50 Hz generator, frequency is given as 50 Hz. On a droop control was delivering 100 megawatt on a droop control was delivering 100 megawatt. So power delivered was 100 megawatt. Due to increase in load, generator power had to be increased by 10 megawatts. So increase in load, generator power is increased by 10. That means it is increased by 10 with respect to previous value, that is previous value is 100, so increased by 10, that is 110 megawatt was the new power. As a result of which the system frequency dropped to 49.75 megawatts. So hertz. So system frequency is 49.75 hertz. So this is new system frequency. Further increase in load, that is load is further increased, okay, resulted in the system frequency of 49.25 hertz. 49.25 hertz. So third frequency is 49.25 hertz at load suppose P3. At this condition, power in megawatts supplied by the generator is, you need to find out up to 2 decimal places. Okay, so P3 you need to find out. So we'll draw a group characteristic. When I am saying it is a group characteristic, the problem is saying it is a group characteristic, that means it is having negative slope. So this characteristic is between frequency and power, okay. So when I am saying this is a group characteristic, so suppose this is frequency F1, so power here is P. Okay, this is frequency, suppose F2, so power here is P2, and this is frequency P3, sorry F3, This one is frequency F3. So power here is P3. Okay, so P3 is a power. So these are two characteristics. Suppose the slope is R. Slope is R. So this is negative R, negative slope. So negative slope is there. Now from this graph, negative slope is given by del y by del x. Now del y is delta f, del x is delta, del x is delta. Okay, so this is negative slope. Okay, so this is negative slope given from this problem rather. Okay, so with this one we need to find out what is the power P3. Okay, what is power P3? Okay. So here from this, what is P3? What is power P3? Delta P. So delta P is equal to minus 1 by R delta F. So delta P, since slope is constant, is equal to delta F. Okay, so from here delta P, that is P2 minus P1 upon P3 minus P2 is equal to, okay, F2 minus F1 upon F3 minus. Okay, so substitute the values. P2 minus P1, 110. This is 110 minus 100. This is 100. So 110 minus 100. So 110 minus 100 will give you 10. Okay. P3 minus P2. So P3 minus 110. That is equal to F2 minus F1. F2 is 49.75. F1 is 49.25. So 49.75 minus 49.25 will give you 0.5 divided by F3. Sorry, this will give you 0.25. F2 is 49.75. F1 is 50 Hz. So this is minus 0.25. F3 minus F2 will give you, F3 is 49.25 minus 49.75. That is, it will give you minus 0.5.